Good morning, students. Now, the next chapter of physics, that is the work energy. What is about the work and what is about the energy, we will study in this chapter. Whenever a force is make a body move, suppose we apply some force on our body. Suppose this is a body of mass m, and we are applying some force on it. If we are applying some force, and this force is more than the friction force which is exerted by the ground on this box, then this box will able to move. So we can say the work is done. Whenever the force makes the body move, then is said to be the work has to be done. And for doing work, we have require some energy. So it means work and energy have some relation between them. So when work is done, an equal amount of energy is used up. So first of all, we are going to write the definition of work. I explained you that when we exert a force on a body and it travel through some distance, then it will say that we are doing some work. It means work work is done when a force when a force produce when a force produces motion. It means when force produce motion in a body, then we say that the work is done. If the force is not enough to produce the motion in the body, we can't say that the work is done. It means the condition which is necessary for the work to be done is that there should be some force exerted on the body and the body should move some distance. So we can say that work done by the force on a body depends on the two factors. Work done by a force on a body depends on two factors. What are these factors on which the work does depend? First one is the magnitude of force. Magnitude of force. What does it mean? Magnitude of force. It means that what is the quantity of force? If you exert large amount of force, the work done will be more, or if you exert less amount of force, the work done will be less. So first of all, it depends on the magnitude of the force, and second one, the distance through which the body moves. Distance through which body moves. Okay, so these are the two factors on which the work is depend. Larger the distance traveled by the body, larger will be the work done, or less the distance traveled by the body, the amount of work done will be less. So we can say the work is equal to, it is the product of the force and the distance. Work is equal to force multiplied with the distance, or we can say displacement or distance. Okay, uh, we denote the work done by using the symbol capital W, and force we denoted by using the symbol F, and distance by S. So we can say W is equal to F into S. Okay, this is the work done. Now what is the SI unit of work done? According to the formula, the SI unit of the work done should be, force has the SI unit of Newton and distance has the SI unit of meter. So it should be Newton meter, or we can say it is joule, Newton meter or joule, represented by J, or we can say joule. Okay, so we can say 1 joule means 1 Newton meter. Now how can you define the 1 joule? We can define the 1 joule like this: 1 joule. 1 joule. When a force of 1 Newton moves a body through a distance of 1 meter in its own direction, it means the direction of force and the direction of displacement should be same, then the work done is known as 1 joule. So you can write the definition here: when when a force of 1 Newton moves a body through a distance of 1 meter, in its own direction, then the work done is known as 1 joule. Okay, this is the 1 joule. You can write here like this: 1 joule is equal to 1 Newton multiplied with the 1 meter. Now, the work is a scalar quantity. Work is a scalar quantity. What does it mean? It means that it has only magnitude without any direction. We know that force is a vector quantity as well as displacement is a vector quantity, but the work done is a scalar quantity. It has only the magnitude, not the direction. The compulsory condition for the work done is this, that when you are applying the force, there should be some displacement. If the displacement is 0, the work done will be 0. Suppose you are pushing a wall. This is a wall and you are just trying to push it. What will happen? Are you able to push this wall? No, it's not possible. So what does it mean? You did some work or not? No, you did not do any work in this case, because there is no displacement by your force. Though you feel some tiredness because your blood circulation goes on increasing and your blood is moving in your body, so there is a displacement in the blood, but overall the displacement in the wall is not happen, so we can say the work done by you is 0. So in the case when you push the wall and the wall doesn't move, it means you don't do any work. So the compulsory condition for doing the work is that by applying the force, object should move some distance. Okay, I think it should be clear. What happens if a coolie is on a station and he has some load on his head and he's not moving at all, then is he did some work here? No. If he is not moving in the platform, it means he is not doing any work. For the work to be done, he has to move some distance. Okay, so there is a compulsory condition that displacement should be there. If there is no displacement, we can say that work done is 0. So in this case, where the coolie is here with the heavy load on his head, he is not doing any work at all because he is not moving. If he start to move from this to any other point, it means he is doing some work. Now, what is the work done when a person is moving against the gravity? Suppose you are traveling through a distance suppose you are moving in a stairs. Okay, you are jumping from here to there. So you are moving in a stairs. If you are moving in a stairs, you are doing some work. So, what is the work done when someone is moved against the gravity? If you are moving upward in upward direction, what are you doing? Actually, you are doing the work against the gravity. Now, the gravitational force which is exerted by the earth is push you in downward direction, but you have to move in upward direction. You have to do some work. You have to spend some energy for moving in upward direction. So what is the work done when someone is moving in an upward direction? Suppose this is a table and you just trying to keep this brick on this table. If you keep this brick on this table, you will do some work. And what is this work will be? This work will be equal to work done. We know that work done is equal to force multiplied with the displacement. Now in this case, suppose the mass of the brick is m. Okay, now we know that according to the Newton second law, we know that F is equal to m into a. So here in this case, when we move something, when we keep something on a table, then we are doing the work against the gravity here. So F is equal to m into a. And what is the acceleration here? Acceleration is due to the gravity. Acceleration due to gravity is the acceleration, that is g. And what is about the displacement? Suppose the height of this table is h. So what is the displacement here? Displacement is h. So what is the work done? What is the work done by u on this brick? This is equal to m, g and h, where m is the mass of the block, yeah, brick, and g is the acceleration due to gravity, and h is the height. So this is the work done against the gravity. You can write here work done against gravity. Okay, this is the work done against the gravity. Here are some numerical based on the work done, which is based on this formula, W is equal to F into S. You know the formula for the F is equal to M into A. So on this formula there is some numerical. One is this: how much work is done? How much work is done? You have to find the work done. How much work is done by a force of 10 Newton. Is it clear? This is the force exerted. In moving an object, through a distance of 1 meter in the direction of force. Now you have to find work done is equal to, we know the formula for the work done is equal to F into S. And what is the value of F here? First of all, you have to write, you should write that what is this in this question, what is there in this question. Like F is equal to 10 Newton here in this question, and we know that displacement is equal to 1 meter. So we can find the work done is equal to F, that is 10, and displacement is 1. So the work done will be 10 Newton. Okay, one more numerical based on this formula, W is equal to F into S. It's very simple questions, really simple questions of work done. Calculate the work done in lifting. Calculate the work done in lifting 200 kg of water. Now this is the mass of the water and we are lifting it, means you are doing some work against the gravity through a vertical height of 6 meter. Okay, now you want to move the water up to the height of 6 meter, which has the mass of 200 kg. Now you have to do some work, and we know that work done is equal to, if you are doing some work against the gravity, then work done is equal to m into g into h. Then what is the value of m here? M is 200 kg. First you have to write the values of this quantity which is given in the question, that is 200 multiplied with the g. G is acceleration due to gravity, so you can put the value of g, that is 9.8, or I'm using here 10, and the height is 6 meter. So 6 to the 12, this is 12,000 joules. Sorry, I'm writing here Newton. This is not the SI unit of work done, it is the joule. Okay, now the work done to lift the water up to the 6 meter is 12,000 joule. So these are the simple questions based on the work done. That is W is equal to F into F is the formula for the work done. Or I think I should do one more numerical of the work done, that is third numerical. A car weighing 1000 kg. Now I am writing only the values which is given in the question. You can write the question here. A car weighing 1000 kg. What is the mass of the car here? This is 1000 kg. And traveling at 30 meter per second. Suppose a car is moving with some velocity. It means it is the initial velocity of the car. This is the 30 meter per second. Stop at a distance of, stop means it is going to be stop, it means its final velocity is going to be 0. Stop at a distance of 50 meter. What is this? This is the displacement, which is 50 meter. I'm reading the question. A car weighing 1000 kg and traveling at 30 meter per second stop at a distance of 50 meter, decelerating uniformly. It means acceleration is negative, which is not given in the question. What is the force exerted on it? You have to find the force exerted on it by the brakes, and what is the work done by the brakes, and you have to find the work done. So first of all, you should clear the chapter first and second, and you are able to do the numerical based on the work energy. So for force, we know that F is equal to m into A. Do you know the value of A? Acceleration? No, we don't know the value of acceleration. So first of all, we have to find the value of acceleration. We know the value of U, V and S. Now, just think, which equation of motion we can use to find the value of acceleration by using these three quantities, these three values. The third equation of motion, that is V square is equal to U square plus 2AS. Here we know the value of V, we know the value of U, we know the value of S, so we can find the value of A. V is 0 is equal to 30 square plus 2 into A into what is S here? S is 50. So 30 square means 900. 900 plus 100A. इसको इधर ले जाते हैं, माइनस में आ जाएगा. 100A is equal to minus 900. या मैं कह रही हूँ इसको इधर ले जाते हैं, ये माइनस में आ जाएगा. Then acceleration is equal to minus 900 upon 100, that is minus 9 meter per second square. This is acceleration. It is negative because the velocity of the body is going to be decreases. So this is acceleration. Now you can find the value of force. Force is equal to m into A. M is 1000 and A is minus 9. So what is the value of force exerted? That is minus 9000 Newton. You know what is the meaning of this negative sign? It means that force is exerted in the opposite direction of the motion of the body. Suppose this body is moving in this direction, then the force is exerted in the opposite direction. So this negative sign shows that the force is exerted in the opposite direction of the motion of the body. So you have to write the meaning of this sign, negative. Negative sign show that force is exerted in opposite direction of motion of the body. Okay. Now, what is the work done? We know that work done is equal to F into S. You know the value of F, that is minus. Now you don't have to write the value of minus sign, because we know that the work done is a scalar quantity. And the displacement, what is the value of displacement here? Is 50. So 9 5s are 45. 4.5 into 10 to the power 3 and 4 and 5. 10 to the power 5 joules. This is the work done. Okay. This is the work done and this is the force. These are some numericals based on the work done. Now in next lecture we will study about what will happen if force exerted is not in a straight line. Suppose we are applying some force obliquely, which means with certain angle, then how can we find the value of work done? Or when work done can be positive, how it can be positive, or how it can be 0, or the negative work done can be possible. So in next lecture we will study about the work done, the positive, negative and 0 work done. Okay, bye.